Pre-secondary, welcome to our method program. Today we have calculus. Our lesson today is methods of integration. Let's start with the differentiation. Definition. Let the function f be a differentiable function on an open interval containing x and delta x. Delta x is denoted for the change in x, where delta x doesn't equal 0. Then, the differential of y is denoted by the symbol dy. dy equals f dash x delta x, and the differential of x is denoted by symbol dx. dx equals dx delta x. dx equals delta x. So, dy equals f dash x. It's a function in two variables. The first variable is x and the second variable is dx. For example, if y equals x to the power 3, then dy equals 3x power 2 dx. The differential of y is dy, and the differential of x power 3 is 3x power 2 dx. Let's start with the first example. Find the differential for each of the following. Number 1, y equals 2x to the power 5. Number 2, v equals 4 over 3 by r to the power 3. Number 3, y equals e to the power 2x minus 3. And number 4, y equals between two brackets 2x plus 5 all to the power 4. Now, number 1, y equals 2x to the power 5. What is the differential of y? Differential of y is dy. And the differential of 2x power 5 is 5 multiply 2x to the power 4 dx. Then dy equals 10x to the power 4 dx. Number 2, v equals 4 over 3 by r to the power 3. The differential of v is dv. And the differential of 4 over 3 by r power 3 is 4 over 3 by multiply 3r power 2 dr. Then dv equals 4 over 3 multiply 3 equals 4 by r power 2 dr. Number 3, y equals e to the power 2x minus 3. The differential of y is dy. And the differential of e to the power 2x minus 3 is e to the power 2x minus 3 multiply the derivative of the power. Power 2x minus 3. The derivative of 2x minus 3 is 2 dx. Then dy equals 2e to the power 2x minus 3 dx. Number 4, y equals 2x plus 5 all to the power 4. Then the differential of y is dy equal the differential of the right hand side, bracket power 4. Then the differential is 4 multiply between two brackets 2x plus 5 all power 3 multiply the differential of the function inside the bracket. Differential of 2x plus 5 is 2 dx. Then dy equals 4 multiply 2, 8 multiply the bracket 2x plus 5 all power 3 dx. Now, the first method of integration, the integration by substitution. The integration by substitution is one of the most initial methods of integration to find the integration of the product of two functions in the form f of g of x multiply g dash of x dx. If z equals g of x is a differentiable function, then the differential of z dz equals differential of g of x, which is g dash x dx, and integration of f g of x multiply g dash of x dx equals integration f of z dz. Example: find integration of x to the power 3 multiply between two bracket 2x to the power 4 minus 7 all to the power 9. By putting the expression 2x power 4 minus 7 equals z, or z equals 2x to the power 4 minus 7, and by differential both sides, then the differential of z is dz, and the differential of 2x power 4 minus 7 is 8x to the power 3 dx. Now 1 over 8 dz equals x power 3 dx. We have integration x power 3 multiply 2x to the power 4 minus 7 all to the power 9 dx. By substitution, then integration between two bracket 2x power 4 minus 7 all power 9, we putting the expression 2x power 4 minus 7 equals z, then between two bracket z to the power 9, and we can replace x to the power 3 dx by 1 over 8 dz. Then now we have a new function 1 over 8 z to the power 9 dz. What is the integration of 1 over 8 z to the power 9 dz? The integration of z to the power 9 is z to the power 10 over 10 plus c. Then the integration equals 1 over 8 times 10 z to the power 10 plus the constant c, and we can write the integration as 1 over 80 multiply 2x power 4 minus 7 all to the power 10 plus the constant c. Another example: find integration of x plus 4 over between two bracket x power 2 plus 8x all to the power 4. We putting the expression x power 2 plus 8x equals z. Then z equals x power 2 plus 8x. By differential both sides, then dz equals the differential of x power 2 plus 8x is 2x plus 8 dx. We can take 2 as a common factor. Then dz equals 2 multiply x plus 4 dx, and we can write half dz equals between two bracket x plus 4 dx. Now the function x plus 4 over x power 2 plus 8x all power 4 dx, we can substitution, then integration x plus 4 multiply dx equals half dz. And in the denominator, x power 2 plus 8x all power 4 equals z to the power 4. Then we have integration of negative of half to the power of z to the power negative 4. Half integration z to the power negative 4 dz. Now, the power plus 1 divided the power n plus 1. Half z to the power negative 3 over negative 3 plus the constant c equals negative 1 over 6 multiply x to the power 2 plus 8x all to the power negative 3 plus c equals negative 1 over 6 multiply x power 2 plus 8x all to the power 3 plus the constant c. Another example. Find integration of 3 minus x multiply e to the power 6x minus x to the power 2 dx. We can choose the expression 6x minus x power 2 and putting z equals this expression. Then z equals 6x minus x to the power 2. By differential both sides, then dz equals differential of 6x is 6 and the differential of x power 2 is negative 2x between two bracket dx. And we can take 2 as a common factor. Then dz equals 2 multiply 3 minus x dx. By divided by 2, then half dz equals 3 minus x dx. Now, what is the integration of between two brackets 3 minus x multiply e to the power 6x minus x power 2 dx? We know that 3 minus x dx equals half dz and 6x minus x power 2 equals z. Then integration of e to the power z multiply half dz equals half integration e to the power z dz. We know that the integration of e to the power z equals e to the power z. Then this integration equals half e to the power z plus the constant c. Now we have another method to integration. Integration by parts. If y and z are two functions in the variable x and differentiable functions, then the derivative of the product of the two functions y and z with respect to x equals the first function y multiply the derivative of the second function, which is dz dx, plus the second function z multiply the derivative of the first function dy dx. Then the derivative of y z equals y dz dx plus z dy dx. By integration both sides with respect to the variable x, then integration dx yz with respect to x equals integration y dz dx with respect to x plus integration z dy dx with respect to x. The left hand side, the integration of the derivative of yz with respect to x is yz, and in the right hand side, the first term, the integration of y dz dx with respect to x is integration y dz, and the integration of z dy dx with respect to x is integration of z dy. Then yz equals integration y dz plus integration z dy. And the integration of y dz equals yz minus integration z dy. The previous equation is called the rule of integration by parts. It's used to find the integration of the product of two functions. Each is not a derivative of to another by a proper choice for each of y and z, such that the integration can be calculated by the left side by a method other than calculating the integration by the right side. Now we have an example. Find integration of x e power x dx. Let y equals x and dz equals e to the power x dx. The differential of y is dy equals dx, and the integration of dz equals e power x dx is z equals e to the power x. Then integration of y dz equals yz minus integration z dy. Then integration the function x e to the power x dx equals y multiply z x multiply e to the power x minus integration z dy, integration e to the power x dx. Now, what is the integration of e to the power x dx? The integration of e to the power x dx is e to the power x plus the constant c. Then integration x e to the power x dx equals x multiply e to the power x minus e to the power x plus the constant c. We can take e to the power x as a common factor. Then integration x e to the power x dx equals e to the power x multiply between two bracket x minus 1 plus the constant c. Another example. Find integration of x power 2 e power x dx. By parts, we can part the function into two parts. The first part, y equal x to the power 2, and the second part, dz equals e power x dx. The differential of y equal x power 2 is dy equals 2x dx, and the integration of dz equals e power x dx is z equals e to the power x. Now, what is the integration of y dz? By parts, the integration equals yz minus integration z dy. Then, the integration of the function x to the power 2 e power x dx equals x power 2 e power x minus integration z dy. Integration e to the power x times 2x dx. Now, what is the integration of 2x e to the power x? Now, we use the integration by parts another time. Then, the equation number 1, which is integration of x power 2 e power x dx equals x power 2 e to the power x minus 2 integration e to the power x multiply x dx. Now let y equal x and dz equals e to the power x dx. The differential of y equals x is dy equals dx, and the integration of e to the power x dx is z equals e to the power x. Now integration y dz equals y multiply z minus integration z dy. Now integration y dz equals y z minus integration z dy. Then integration x e to the power x dx equals x multiply e to the power x minus integration e to the power x dx. Now, what is the integration of e to the power x dx? Yes, integration of e to the power x dx is e to the power x plus c. We can take e to the power x as a common factor. Then the integration of x e to the power x dx equals e to the power x multiply x minus 1 plus the constant c. And this relation is the relation number 2. From 1 and 2, then integration x power 2 e power x dx equals x power 2 e power x minus 2 e power x multiply between two bracket x minus 1 plus the constant c. And we can take e to the power x as a common factor from the right hand side. Then the integration of x power 2 e to the power x dx equals e to the power x multiply x power 2 minus 2x plus 2. Dear students, note that choosing y and z or y and dz is based on number 1, dy is simpler than y. Number B, dz is either than integration. Another example, find integration of x to the power 3 ln x dx. Integration of x power 3 ln x dx. Now, the function ln x used by the differentiation of ln x, because ln x has no integration rule. Then we put ln x and x power 3 dx. The derivative of ln x is 1 over x dx, and the integration of x power 3 dx is x to the power 4 over 4. Then the integration equals x power 4 over 4 ln x minus integration x power 4 over 4 times 1 over x dx. Then integration of x power 3 ln x dx equals x power 4 over 4 ln x minus quarter integration x power 3 dx. What is the integration of x power 3 dx? Yes, x power 4 over 4 or quarter x power 4. Then integration x power 3 ln x dx equals x power 4 over 4 ln x minus 1 over 4 multiply 1 over 4 x to the power 4 plus the constant c. Then the integration equals x power 4 over 4 multiply ln x minus 1 over 16 x to the power 4 plus the constant c. And by this example, we come to the end of our program today. Until we meet again, it's goodbye.